Unified dynamics. Distinction theory.
We usually think of motion as something happening across a blank canvas. An object travels through a void, a background of nothingness that offers no resistance and plays no active role in the journey. Underneath that apparent emptiness lies a rigid, interconnected structure. In unified dynamics, the void vanishes, replaced by a dense grid of discrete geometric units. This right here is the K4 packet network. It treats space as a physical machine built from billions of tiny tetrahedral processors. Because the arena itself is a network, reality is governed by the same things that govern any computer: rigid algorithmic rules and strict data capacity limits. Motion, then, is a fundamental transaction. For an object to move from one point to the next, it has to negotiate with the local geometry of the lattice, essentially buying space as it goes. To see how that negotiation works, we have to look at a single vertex in the network. Each vertex holds a specific amount of localized computational debt, a backlog of updates we call burden. Every node has a hard capacity limit. This vertex can hold a burden of precisely 7/768. If the load exceeds that number, the local math stops working. Approaching that ceiling creates topological diffusion pressure, an outward radiating force pushing back against the network. To stay below the collapse threshold, the vertex executes an emergency survival protocol. It refuses all new incoming data and violently shunts its current burden out into the surrounding geometric network. This is the engine of the universe. Every physical event is driven by these microscopic nodes frantically trying to avoid an algorithmic crash. The expelled debt navigates the tetrahedral cell. First, the burden expands onto 3 incident faces, a 4/3 asymmetric expansion. Next, it consolidates onto structural edges, locking into a stable 3/2 multiplier. This algorithmic step function creates a continuous breathing rhythm throughout the network. Because every vertex has that 7/768 capacity limit, a node that is already full simply refuses to accept more data. This hard veto creates a physical lockout between packets. This microscopic no-vacancy sign is the origin of Pauli degeneracy pressure, the fundamental force that prevents matter from overlapping and keeps the universe from collapsing into a single point. This violent microscopic breathing is happening at structural scales far below what human eyes can ever possibly see. The network recalculates these geometric shifts trillions of times every second. These discrete, jagged jumps happen so fast that they blend into the appearance of perfect fluidity. Kinematic motion occurs as the lattice frantically and sequentially reassigns structural debt from one node to the next. What we see as a smooth glide is actually a lightning-fast data transfer protocol. When we zoom out to the broader macroscopic level, we see exactly how billions of these nodes interact. If every saturated node is pushing its debt outward to stay functional, the excess burden has to go somewhere. The network manages this through topological trajectory bias. In this system, matter isn't an object inside space. It's a massive backlog of trapped updates circulating through these loops. A star or a planet is simply a colossal concentration of local burden. The network's algorithms are biased toward nodes with more breathing room. It routes traffic away from congested heavy areas and toward empty regions that have the capacity to handle the load. This creates massive routing gradients. The traffic of the universe naturally bends away from clusters of debt and toward the open capacity of the surrounding void. We see the effects of these gradients on a cosmic scale, shaping the paths of planets and the rotation of galaxies. This algorithmic preference for empty space is exactly what we observe as gravity. Because matter is the burden, the lattice's attempt to move that burden into empty nodes manifests as a physical pull. Space-time curvature isn't a fundamental fabric. It is the statistical average of this microscopic traffic management system operating at equilibrium. Pushing an object and being pulled by gravity are the same logistics in action. Both are signatures of a universal discrete network, constantly rerouting debt to keep its own geometry from failing.